Hello everyone. So now we are going to present the pale Lajak Kuih for you guys for the meeting, and there's 200 samples over here that we have taken, so we have already compiled it into different kind of graphs with tabular methods. So I'll leave it for Elsam to present over here. So Elsam, take it away.
Thank you for passing it to me, Robert. I'll take it from here. My name is Islam Ramadan, and I will present on the key points and differences in the parameters of our graphs. To start off, the data was given to our group in this raw form. The key points we are interested in are weight, relative density, tensile strength, and the shifts that the pill was produced on. By analyzing this data, we produce these set of graphs where we can compare other points of interest for our parameters. That includes the sum, the max, the minimum, the standard deviation, the variance, the mean, and lastly, the median. These graphs showcase the overall given data. To summarize quickly, I will go over the key interest points of each graph. When it comes to weight, we can notice that the most weight produced was at the night shift, and that's significantly higher than the morning and the evening shift. In comparing the max categories based on the same parameters, which were the weight, relative density, and tensile strength, we can notice that there's not a big difference between the shifts. That goes as well for the mean, minimum, and with a slight difference in the morning shift at the standard deviation. When it comes to frequency of production based on shifts, we can notice that most of the pills are produced at the night shift. And when it comes to variance, we can notice that there is a significant difference between the three shifts. Lastly, when it comes to median, we can notice that there is minimal to no difference between the different shifts. That's all from me. Now I'll pass it to my next teammate.
Hello everyone, this is Ong Yi Kai from Lajak. So as a member of the team, my responsibility is to make sure and analyze the data of our weight of the tablets. So let's get started. So based on this data, I calculate the mean and the standard deviation of the tablets weight using the Excel formula. The FDA requires the manufacturer to produce the mean weight of our tablets to be 350 and the standard deviation of 40 milligrams. So I run a statistical test called the Ssce test to see whether or not our mean weight is within the standard of FDA or not. So yeah, here is it. First of all, I made an assumption where the mean weight of the tablet is 350 milligrams and an alternative hypothesis which isn't. So I use a significance value here, 0.05. Significance value means that how strong your evidence to support the hypothesis. So the smaller the significance value, the higher or the stronger the evidence to support the hypothesis. So I calculate the Z score using the significance value from statistical table to see, it's actually plus minus 1.96. So I draw a Z score graph and then plot both sides of it. Each end I label 1.96 and negative 1.96. Then we use this formula Z test from our data to calculate whether or not the Z test fall inside this unshaded region or outside the shaded region. So if inside the shaded region means that we need to reject this hypothesis. If it falls inside this region, we need to accept this hypothesis. Yeah. So based on my calculation, I found that for this significance value, here is the Z score and so on. And then our Z test calculated is within the range of this score, meaning we need to accept our null hypothesis, and there's no difference between our mean standard and the FDA one. So for the standard deviation, I use the same method, just that I use different graph called chi-square graph. This happens because we are calculating the standard deviation, not the mean. Okay, here same, we use the hypothesis and hypothesis alternative. And then in this graph, I draw the graph also, it's called chi-square graph, and then same, plot both ends, and then calculate this value, chi-square value from the statistical table with the significance value. And then I use this formula to see whether or not the chi-square curve fall inside this region or inside the shaded region. So based on my calculation, the chi-square fall inside the unshaded region. Yeah, that means we need to accept our null hypothesis, which there's no significant difference between our standard deviation and the FDA's one. So here comes the part 2. Basically, we need to compare is there any significant difference between the morning, evening, and night shift weight. So we use this data and then we use the Excel formula to run for us a test called ANOVA test. So basically this is the F test value and this is the F critical value. This is the P value. So if F more than the F critical, we need to reject our null hypothesis. And when the p-value more than the alpha value, we need to accept the null hypothesis. So in this case, this F value is less than the F critical and the p-value is more than our alpha. So we need to accept the null hypothesis where there's no significant difference between the weight of the morning, evening, night shift of the tablets. Thank you so much. That's it from me.
Hi everyone, my name is Wen Qing, and as a member of group, my job is to conduct linear regression tests to test the validity relations between relative density and tensile strength of the tablets. So I'm using significance level of 5% for the whole testing. So in order to conduct linear regression tests, there's two methods. The first one is correlation method, and the second one is ANOVA test. So after we're done inserting the 200 data into the data analysis for regression in Excel, and this is the result we got. So the first thing is value of out. So in this case, the value out is 0.8444, which shows a very strong positive linear relationship between relative density and the tensile strength of the tablets. So the second thing is the out square. Out square actually brings the meanings of how is one variation of variables brings effects to the another one. So in this case, we have the out square values of 71.3% saying that the relative density brings effects or changes to the tensile strength. So the next thing we move on to ANOVA test. So in ANOVA test, after we've done every calculations, the final significance F value we got is 1.41 times 10 power to negative 55. So which is then we compare with our significance level, which is 5%, just I mentioned just now. So as you can see, the significance F value shows to be lower than our significance level value. So that means we can have a very strong evidence to say that there is a existence of linearity relations between relative density and our tensile strength. So in conclusion, both analysis and test shows that there is a linearity relations between the relative density and the tensile strength of the tablets. That means any changes or any variation in the relative density actually brings effects and changes to our value of tensile strength of the tablets. So last but not least, we have another additional supporting evidence that we comparing the p-values with our significance level. So the same result we got is that our p-value is smaller than our significance level, and this implies the meanings that there is a linearity relationship between both variables. So that's all from me. Thank you.
Hi guys, I'm Pauline. So today I will present the engineering statistics assignment part D which is done together with my teammate Wen Qing. So our leader is Nicholas. They helping. So I'm going to start right now. So basically, we have done for the my teammate Wen Qing is already done for part D step 1, which is a linear regression test. We actually using by the data all this given. We actually extract it out to become like this by using a data analysis. So this is the data that we get, which is the R square multiple R, and so after we get an ANOVA test value as well. So we get a significant F and the DF, SS, MSF. So this is the things that being given as well. So after let's go back to the report. So after we been carry out the regression statistic and the ANOVA test, so the conclusion is actually both of the correlation relationship between relative density and tensile strength is actually linear related. So in this relation, any changes in relative density will bring the effect and the changes to the value tensile strength of the table. So this is a little bit additional supporting evidence. So you can see the p-value for the gradient, right, is very, very low, as here mentioned here. So then choosing the significant value. Also the significant value is So the gradient is significant, not 0 at 5% significant level. So actually this is accurate one. So the step that I being carried out is actually step 2. I'm going to predict the tensile strength by given density. So the solution that I take is actually I'm going to perform the linear regression and apply the regression equation. So according to this data extracted by data analysis, we have do this linear regression equation here. So the equation is actually y equal to alpha plus beta x. So the equation that we have is actually y equals to 0.2326 plus 0.07858. So this is our data linear equation data, and the maximum relative density is actually 94.4 and minimum relative density is actually 82.0. So for this table relative density, all of the data is actually calculated between the 82% and the 94.4%. So how we get all this maximum and minimum is actually through this equation. So you can see the maximum we actually use this formula, and the minimum we actually use this formula to figure it out. So it's very accurate. So after this, according to this line fit plot, so the x is actually the relative density that being given and the tensile strength as well, predicted tensile strength. So by applying the regression model and predicted by applying the regression model and predicted tensile strength by given the relative density, so there is a tree plot that we being taking out from the data, from the graph here. So here is the data. So when the relative density is actually 85.3%, the predicted tensile strength is actually 6.9352. So when the relative density is actually 86.5 and the predicted tensile strength is actually 7.0295, so you can see it actually keep on increasing. So when the x is increasing, then the y is increasing as well. So the last one is actually 91.7% of the relative density, and the predicted tensile strength is actually 7.4381 m Pascal. So the relationship is very clear, which is the linear proportional. So something to take note will be this prediction is actually only between the 82% and the 94%, and it should be tested and checking with the real life tensile strength value. So it will be much more accurate in the data, because extrapolating the tensile strength for relative density value outside the test regression might or may be yet an accurate linear prediction. So it should be counter-checked again with the real life value, because this is just according to the between the 82% and 94.4% of the relative density. So here is the data that will be extracted out as well, which is the normal probability plot. So you can see the predicted line here is actually linear proportional as well. So here is the relative density radiation plot as well. So that's all from our job. Yeah, thank you so much.